how to find the length or the exact measurement. So this is a formula sheet that you're going to be able to use on the EOCT, so I want you to get comfortable using it. We have already experimented using this part of the formula sheet, which we used with the right triangles, and we're going to be looking at a different part of the formula sheet now. Right here is talking about circumference, and circumference, this is another name for perimeter around a circle, and since a circle doesn't have sides, we don't call it perimeter. We call it circumference. So these are the two formulas we're going to be using in the lesson tonight and what you will be applying and using tomorrow in class. Remember, the circumference or the perimeter of a circle is the distance around the edge of a circle. That is the definition. I looked it up on the internet. Again, this is the formula that you find on your formula sheet for circumference. All right? And what we want to be able to do is we want to be able to find the circumference regardless if we're given the radius or the diameter. In the first example right here, it tells us that the radius is 7, and I know that's the radius because it goes from the center to the circle. So that means we're going to be using the second formula right here, which would be C, which stands for circumference, equals 2 times pi times r. So if I want to find the exact value, what I'm going to do is I'm going to substitute in 7 for r, since r is a radius. So that'll give me 2 times pi times 7. And I'm going to multiply my like terms, so that gives me 14 pi. All right, if I want to find an estimated measurement for that circumference or the distance around the circle, all I do is I take my calculator and I multiply 14 times pi. And the pi button is right next to the ANS button, the answer button, so I would press Shift pi, and that's going to give me 14 pi, and I have to hit the SD button to get 43.98, and I'm going to just round to the nearest hundredth, so I need 2 decimal places. So the exact answer would be 14 pi, and the estimated answer would be 43.9. For the second example, this one's a little bit different because this example tells me that the distance across the circle through the center, the diameter, is 20. So in this case, I would need to use the first formula because D stands for diameter. So that would give me C, which stands for circumference, equals pi times D, which is 20, or simply 20 pi. If I wanted the estimated answer, I would put 20 pi in my calculator, so I would press 20, Shift, pi, press equals, and then again I would need to press my SD button, and it's going to give me 62.83. So in both cases there, I found the circumference using either the formula that has the radius or the formula that has the diameter. On these examples here, they're a little bit different because these examples tell you what the circumference is. In the first example, it says the exact diameter, they want you to find the exact diameter of a circle with a circumference of 29 feet. So if I know the circumference is 29 feet, I'm going to substitute 29 in for C. And since I want to know the diameter, I'm going to use the first formula right here. So that equals pi times D. And if I want to solve for D, I want to isolate the D. I want to get the D by itself. So what I need to do is, since it's multiplying pi times D, I'm going to divide both sides by pi. The pi's cancel here. And this is what I put in my calculator. So in my calculator, I could either press the fraction bar and put 20 over pi, or I can say 20 divided by pi, since that's what a fraction means to do. And it's going to give you an estimated answer of 6.366, which I'm going to round to be 6.37. Example 2. Example 2 wants me to find the exact radius of a circle with a circumference of 36 centimeters or 36 meters. So again, that tells me that my circumference is 36. So I've got to use this second formula since I want to find radius. If C, I can substitute a 36 in for C. So 36 equals 2 times pi times r. So if I want to solve for r, I need to isolate the r. So I'm going to divide both sides by 2 pi. That way the 2's cancel and the pi's cancel. So again, in my calculator, I can press 36 over 2 pi, or I can simply say 36 divided by parentheses 2 pi. Now you need to use your parentheses here, so you divide by both the 2 and the pi if you hit divided by. So again, that gives me an estimated answer of 5.2729, so I'm going to say 0.73. The 9 makes the 2 round up to be a 3. So make sure that you substitute in the numbers for the correct variable that they represent, and then solve for the letter that you want to find.
Toss out of here.
That's fine. All right, now the standard that we're working on now says derive using similarity the fact that the length of an arc intercepted by an angle is proportional to the radius. Now if you look at these two arcs that I have highlighted in yellow and in purple, all right, those are arcs because they're part of a circle. And do you agree that they both go with the same 90-degree angle because they both have the same central angle? So they're going to be proportional to the radius because the radius for the yellow arc will be much larger than the radius for the purple arc. So that's why we're going to be talking about that. All right, now remember that arcs are only a part of a circle. So that way, what we're going to have to do is we're going to have to find the part of the circle. It is the distance around, so we will use the circumference formula. And the following are just examples of how to find the arc length. This question wants me to find the arc length from A all the way around to B. All right, so the easiest way to do that is let's find the circumference of the whole circle. If I want to find the circumference of the whole circle, I'm going to say C equals 2 times pi times 6, because 6 is my radius from A to Q. So that's going to give me the circumference of the whole circle is 12 pi. And I'm just going to use the exact answer because there's no sense in estimating right now. The problem is I don't want to find the circumference of the whole circle. I only want to know how far it is from A to B. Now remember that a whole circle has 360 degrees. So if I'm only using 120 degrees, I'm only using that part of the circle. So I would say 120 divided by 360 would give me the part of the circle that am interested in. And I want to know the part of the distance around, so I'm going to multiply that by the circumference, because I only want to know part of the circumference. So the arc length is going to be the part of the circle, which is 120 over 360. If I put that in my calculator using the fraction button, I put 120 over 360. And then I use parentheses, 12 pi to show it multiplication. And it tells me my answer is 4 pi. Now that is an exact answer. If I want to find the estimated answer, I have to hit the SD button, which would give me 12.566, which rounds to be 12.57. So the only difference between finding the arc length and finding the circumference is that you have to multiply by the part of the circle that you're interested in, and a part will be represented by a fraction. Here's another example. I want you to find the arc length from A to B. So I would need to use my circumference formula, which C equals 2 times pi times radius, which in this case is 12. I can multiply 2 and 12, so it tells me my circumference is 24 pi. Now again, I wouldn't bother to find the exact or the estimated answer here. I know I don't want to know the whole circumference around the whole circle. I only want to know the part from A to B. So that part is represented by 45 degrees out of a total of 360 degrees. And I multiply that by the circumference of the whole circle, which is 24 pi. So what again I do, I get my calculator out and I say 45 over 360. That's the part of the circle I'm concerned with. Parentheses, 24 shift pi. And that tells me my answer is 3 pi. That is the exact answer. And if I want the estimated answer, all I got to do is hit the SD button. And that gives me 9.424, which would remain 9.42. And that's how you find the arc length. You just use the circumference formula and multiply by the part of the circle that you're concerned with. Now in this example, they're wanting us to find the radius. I know that the angle is 90 degrees. I know that the arc length is 18 pi. So in order to find the radius, what I'm going to have to do is work backwards. So I'm going to start with 18 pi. That is my arc length. And I know that the way to find the arc length is I multiply by the part of the circle. And the part of the circle in this case is going to be 90 out of 360 degrees. And I'm going to multiply that by the circumference, which would be 2 times pi times r. So in order to solve for r, I would need to undo everything that's happening here. So what I'm going to do is everything here is multiplied by r. So what I'm going to do to get it to cancel out is I'm going to divide both sides by 90 over 360. Those cancel here. So if I use my fraction button and I say 18 shift pi in my numerator, and then in my denominator I put 90 over 360 and hit equals, that gives me 72 pi equals 2 pi r. Again, I'm wanting to solve for r, so I need to isolate the r. So to isolate the r, I need to get rid of the 2 and the pi. So I'm going to divide by both sides by 2 pi. The 2's cancel and the pi's cancel. So in my calculator, again, I'm going to press the fraction button. So I'm going to put 72 shift pi in my numerator. And I'm going to put 2 shift pi in my denominator. And that would give me r equals 36. So my radius is 36. You can always go back and check it by putting it back in the formula. I could say 90 over 360 times 2 times pi times 36. And see if I get 18 pi. So if I did that, I would say 90 over 360, parentheses, 2 shift pi times 36, and check my answer, and I get 18 pi, so I know I got it right. In this example, they want me to find the circumference of circle Q. In order to find the circumference, I need to know the radius, because the circumference formula is circumference equals 2 pi r. And I notice from this problem that I don't know the radius. I know that the arc length from A to B is 15 inches, and I know that the central angle is 60. So I'm going to say the arc length is 15 inches. I know that's part of the circle, 60 over 360. And I know I multiply that by the circumference, 2 pi r. So in order to solve for the circumference, I'm going to divide both sides by the fraction. So I'm going to divide both sides by 60 over 360. They cancel on the right. I get my calculator out and I say 15 divided by fraction 60 over 360 equals, that would give me 90 equals 2 pi r. And really, I don't even need to go any further than that because 2 pi r is my circumference formula. And if I wanted to find the circumference, I know that my circumference would have to be equal to the circumference formula. So I found the circumference there. So these are all the examples that I have for today. We'll work some more of them in class tomorrow.